compound interest problems. Compound interest problems. These compound interest problems can be solved in various methods. One is a formulae method. One is a formulae method. And another is an successive percentage method. Successive percentage method. Successive percentage method. And another is a tree method. Another is a tree method. And another one is a answer options method. Answer options method. To be more precise, digital sum method. Digital sum method. Next one, fifth, GP method. All these concepts we are going to discuss. GP method. Next is sixth variety is problem specific method. There could be a variety of questions. A particular approach is used to solve a particular kind of problems. These are the 6 methods that are used in compound interest problems. In the forthcoming classes, I will introduce these the most powerful concept. Today definitely I will give an idea of why compound interest uses this GP method. Formulae method. As most of you know, what you will do is amount is nothing but P into 1 plus R percentage power n, and amount equivalent to principal plus compound interest. This is what you will use in most of the textbooks. This was an outdated method. Probably very less number of sincere and smart students are using this method. Next is successive percentage method. A plus B plus AB by 100 percentage method. This method also good number of people are using, and this is also an outdated method, right? What is the concept we are using? Instead of this one, product of two parameters is constant. Go back and see session number 2. You will understand how this formulae method can be eliminated. Next it is a tree method. Yesterday we discussed it. Answer options method, GP method, and problem specific method. These are the 6 various methods to solve compound interest based problems. Anything which is a particular variety and it is defined only for amount is double, right? The relationship between the time period and rate of interest is n is approximately equivalent to 72 by R. This kind of problems comes under the problem specific method. Answer options method, GP method, digital sum method. Now let me address these. Yesterday we discussed point number 3. Let me address these point number 4. Answer options method. But before that answer options method, let us write down some important key points. Compound interest. Compound interest. Some important key points every student should know, so that you will solve each and every problem right very logically. In compound interest problem, in simple interest, rate of interest is same every year. In simple interest, rate of interest is same every year. Every year rate of interest it is same. Because it is same, simple interest is nothing but an additive method. Simple interest is nothing but an additive method. Additive method. What do you mean by an additive method? Suppose the rate of interest is 10%, and it is 3 years, What is the effective rate of interest? In case of simple interest, rate of interest does not changes. First year 10, second year 10, third year 10. So total it is nothing but 30%, which is nothing but first year 10, second year 10, third year 10. Totally it is nothing but 30%. Simple interest is always an additive method. Next one, in compound interest, rate of interest changes every year. In case of compound interest, rate of interest changes every year. Same question if I take R percentage is 10%, N is nothing but 2 years. So simple effective rate of interest under SI is nothing but 10 plus 10, which is nothing but 2 into 10. Simple interest, it uses addition. Simple interest, it is nothing but an additive method. Now, in compound interest, 10% is nothing but 1 by 10. Initially, I gave 10 rupees to my friend. He has to give me after 1 year 1 rupee more, which is nothing but 11. Second year also 10, 1 rupee more, 11. 100 becomes 121. Extra is nothing but 21 percentage. Extra is nothing but 21 rupees on 100, which is 21 percentage. That means if you observe, SI for 2 years is nothing but, if I take for 2 years, SI is nothing but 20 percentage and CI is nothing but 21 percentage. From that means from the second year onwards, the CI value, CI value will keep growing more than simple interest. Like we said, SI is an additive method. Compound interest is a multiplicative method. Compound interest is a multiplicative method. What do I mean by multiplicative method? Let us see. In compound interest, in case of compound interest, right, we use multiplicative method. Now, what do you mean by multiplicative method? Listen carefully, sir. This is a very, very important note. Multiplicative method, or in other words, right, in case of compound interest, ratio remains the same. Ratio of amounts remains the same. Ratio of amounts remains the same. What do I mean by ratio of amount remains the same? Listen carefully here. Example. P is nothing but 100. R is nothing but 10 percentage. R is nothing but 10 percentage. So initially the sum borrowed is nothing but 100. After 1 year, 100 10 percentage more is nothing but 110. Right? In the second year, there will be an interest on interest. This is nothing but 10 percentage of 110, which is nothing but 11 addition. This is nothing but 121. Amount after third year, there will be interest on interest, 10 percentage of 121, which is nothing but 12.1. Amount is, in case of compound interest, amount at the end of the year, whatever the final value that you get at the end of the year, amount at the end of the year becomes the principal for the next year. It becomes the principal for the next year. Final value of at the end of the year becomes the initial value for the next year. 10 percentage of 121 is 12.1, which is 133.1. Listen carefully. I went to a friend and I took 100 rupees from him. Because I am using 100 rupees, his money, he said, at the end of the year, you pay me my 100 rupees. For 1 year, I am not asking you anything. For that reason, you have to pay me 10 rupees extra on 100. So, after 1 year, when I meet my friend, I give him not only his 100 rupees, but 10 rupees extra. 100 plus 10 is 110. Amount at the end of the first year becomes the principal for the next year. Beginning it is 110. He uses 110 entire for the second year. At the end he gives 10 percentage of 110, which is 11 extra. So at the end of the second year he gives 121. At the end of the third year, amount at the end of the second year 121. That becomes the principal for the third year, which is 121. He uses that 121 for the third year. At the end of the year, he gives 10 percentage of 121. 10 percentage of 121 is 12.1. 121 plus 12.1, which is 133.1. Now, why did I say that it is a multiplicative method? But see here, this is the initial principle. 10 is to 110. 0 cancel. This is nothing but 10 is to 11. This is nothing but 10 is to 11. Am I right? So, if I take 100 and 110, 100 and 110 is in the ratio how much? 10 is to 11. 100 is the initial value. After 1 year, I will give 110, which is 10 is to 11. Now, always remember, sir, ratio of the amounts remains the same for every year. it is 10 is to 11. Next two consecutive values, it should also be 10 is to 11. It should also be 10 is to 11. Now see here, this is 10 is to 11. So this should also be 10 is to 11. This should also be 10 is to 11. Are you all with me? Now see here, 10 becomes 110. So 10 into 11 is 110. 11 into 11 is 121. Are you all with me? Or you look at like this, 11 into 10 is 110 and 11 into 11 is 121. First ratio it is into 10 and it is into 11. Initial value is multiplied by 10, final value is multiplied by 11. In the next two also, this should be multiplied by 10, this should be multiplied by 11. Are you all with me? Next one, again it is of the form 10 into 11. 10 into 12.1 is 121. 11 into 12.1 is 133.1. That means, listen carefully, sir. Suppose there are 5 consecutive years it is given. If these ratio is x is to y, these two ratios also should be x is to y. These two ratio also should be x is to y. These two ratio also x is to y. I hope the idea it is clear. I hope the idea it is clear. Suppose the principal is 200 and the amount for right first year is 242. What is the amount after second year? R is nothing but 10%. R is nothing but 10%, which is 1 by 10. Now if you see here, this is nothing but initial value 10, final value is 10 plus 1, 11. The ratio that should be maintained is nothing but 10 is to 11. So this is 10 is to 11. 10 20s are 200, right? 10 is to 11. So these is nothing but 11 20. 2s are 242. Why? Because 20 and 22 are, I will simplify it further. I will simplify it further so that you will understand it clearly. 200 and 242. These are nothing but 100 and 121. 100 and 121. This should be in the ratio 10 is to 11. So these 10 10s are and it is 11 11s are. I hope it is clear. This should also be in the form of 10 is to 11. This should also be in the form of 10 is to 11. So these are nothing but 100 121. Just now we got the value 133.1. It is into 10 into 11. This also it should be into 10 and it is into 11. So it is nothing but 11 into 12.1. I hope it is clear. Another way to look at this question is, I hope the idea it is clear. Ratio between the initial value and the final value. Ratio between the initial and final. Ratio between the initial and final, it should be same. Or in other words, if the ratio is same, multiplication factor should be same. If you are getting confused with respect to ratios, multiplication factor should be same. What is that? We will discuss. Multiplication factor should be same. Multiplication factor should be same. What do I mean by multiplication factor? I went to my friend and I took 100 rupees. After first year, I will give 110. After second year, I will give 121. After third year, I will give 133.1. 100 is becoming 110. What is the multiplication factor? Which is nothing but 1.1. Are you all with me? The multiplication factor should be same. 110 into 1.1, which is nothing but 121. It is nothing but into 1.1. Into 1.1. Again it is 133.1. This is nothing but 121 into 11 by 10. 12.1 into 11, which is 133.1. 110 into 11 by 10, which is 121. 100 into 11 by 10, which is 110. That means in case of compound interest problems, multiplication factor should be same. Multiplication factor should be same. See, these both are same. Suppose if I take an example of a GP series 4, 6 and 9. 4, 6 and 9. Multiplication factor is 1.5. Here also it is nothing but 1.5. Ratio if I take 6 by 4, 6 by 4, which is nothing but 3:2. Here also it is nothing but 3:2. When I say ratio is same, that is also means multiplication factor should be same. Extremely important point, because the multiplication factor it is same. It is multiplication factor, it is same. CI is nothing but a multiplicative method. SI is nothing but an additive method. SI is an additive method because the value will keep growing in an addition function. In case of compound interest, the values are getting multiplied. CI is an multiplicative method. I hope the idea is clear. Because the multiplication factor is same, if the multiplication factor is same, all the values are in which progression? Geometric progression. Please write down. Very, very important point. In case of compound interest problems, P, A1, A2, A3, A4, amount after first year, all these consecutive values, they are in which progression? They are in geometric progression. They are in geometric progression. P, A1, A2, A3, A4. That means another important key point, if A, B, C are in geometric progression, then B square equivalent to A into C. That means B is nothing but square root of A into C. Extremely important point, if three amounts in consecutive years, if it is given, then the middle amount A2 is given by root of A1 into A3. Root of A1 into A3. Similarly, if A3, A4, A5, if they are in GP, A4 is nothing but root of A3 into A5. I hope the ideas are clear. Because the multiplicative factor is same, that means all the values, right, in compound interest, which is amount A1, A2, A3, A4, A5, all are in geometric progression. If they are in geometric progression, ratio between the consecutive terms is the same. B by A equivalent to C by B, which is nothing but B square equivalent to A into C. Very, very important point. Very, very important point. If three consecutive amounts are given in the question and the middle amount he is asking, middle amount is nothing but the geometric mean of the previous and after amount. A2 and A4 in this case are called the geometric means. In this case are called the geometric means. It's extremely important for you to understand the concept. Once you understand the concept, then solving the problems is very, very easy. I hope this is clear. Why SI is additive method? I hope it is clear. Why CI is multiplicative method? Idea, I hope it is clear. Next one, I hope why this is nothing but right? Are you facing any audio issues? Idea clear, right? Idea clear? Now we will solve some problems. Once you understand, all this will be extremely easy to use, sir. Amount after 3 years is 36. Amount after 5 years is 49. What is the amount after 4th year in the case of compound interest problems? In the case of compound interest problems, listen carefully. So A3, A4, A5, A3, A4, A5, they are in geometric progression. So A4 is nothing but root of A3, A5, root of 36 into 49, 6 sevens are 42. 6 sevens are 42. Amount after 4 years is nothing but 42. Still we will discuss in detail, because I told you that CI uses GP method. I am just giving an introductory understanding of why CP uses GP method. One more example. AI is nothing but 9. A9 is nothing but 12. A10 it is nothing but how much? In the case of a compound interest problems, so A9 square is nothing but A8 into A10. So 144 is nothing but A9 into A10. So A10 is nothing but 16. A10 is nothing but 16. What is A? These the amounts. These the amounts. Very, very important point in the case of compound interest problems, right? 3 consecutive amounts will always be in geometric progression. Ratio between initial value and final value will be same, right? Point number 1. And point number 2, if the ratio is same, multiplicative factor will also be same. I hope you got an understanding of this concept. I hope this idea is clear. So next, one more application of when to use digital sum method. I will also tell you the when not to use this concept, digital sum in compound interest. How to apply digital sum in compound interest? Digital sum, right, in compound interest, when it is applied. Disclaimer, these digital sum in compound interest is applied when answer options are present. If answer options are present, please use these digital sum concept. Point number 2, right? When the digital sum of answer options, when the digital sum of answer options are not same, when digital sum of answer options are not same. And the next point, digital sum is an elimination method. Digital sum is an elimination method. What do you mean by elimination method? It will eliminate incorrect answer options. It will eliminate incorrect answer options. It will never give you the right answer options. It will definitely tell you which all answer options are incorrect. Which all answer options are incorrect. All these important key points are need to be noted before you use a digital sum. Anyway, after some time, I will give a table when to use which concept. Digital sum is used when the answer options are present. Digital sum of the answer options, if they are not same, then this method efficiency will grow. It is used to eliminate all incorrect answer options. It does not give you the right answer option. If the digital sum is not matching, then that option is incorrect. These are the important 3 key points to be noted while solving compound interest problems using digital sum. Please write down the first question. Please write down the first question. P is nothing but 5,000. P is nothing but 5,000. R percentage is nothing but 18%. N is nothing but 2 years. Amount is how much? Options 6762, 6862, 6962 and 7062. 7062. This is in CI. Entire classes are in compound interest first, because that is where most of the students will get, right, little intimidated, right? P is 5,000, R is 18%, N is 2 years, amount is how much? Amount is how much? Yesterday I told you a tree method. Yesterday I told you a tree method. In this tree method, compound interest is nothing but SI plus interest on interest. SI plus interest on interest, CI, right? So there is first year and there is second year. There is first year and it is second year. Suppose the principal is 5,000. First year SI is nothing but 18% of 5,000, which is 900. Second year also it is SI. Interest remains same for every year. These also nothing but 900. 900, 900, right? CI in the second year, it is SI for first year, SI for second year. CI is nothing but SI plus interest on interest. So 18% of 900, which is nothing but 162. 162. This is the first year interest. This is the second year total compound interest. So total amount is nothing but principal plus compound interest for 2 years. Principal is nothing but 5,000. CI for 2 years is 1962. So answer for this question is 6962. This is the tree method. Yesterday we discussed so many problems based on tree method. CI is nothing but SI plus interest on interest. In case of first year, SI and CI both are same. In case of first year, SI and CI both are same. 18% of 5,900, 900. 18% of 900 is 162. So 900 plus 900 plus 162. Answer is 6962. Answer is 6962. If you know this concept, you can solve it like this and get the answer as 6962. Now, in case if you are an Anil Nair student, how you should solve? P is 5,000. P is 5,000. R is nothing but 18%. N is nothing but 2 years. Amount is how much in the case of a CI? Now, you should know amount is nothing but P into 1 plus R percentage. P into 1 plus R percentage power n. Even if you do not know also, you can solve that also I will show. These 5,000. 1 is nothing but 100%. R is 18%. Power 2 years. So these nothing but 5,000 into 118 by 100 power 2. 5,000. What is the digital sum? Digital sum is the sum of the digits till you get a single digit number. 5 plus 0 plus 0 plus 0, 5. 1 plus 1 plus 8. These nothing but 118 into 118 divided by 100 into 100. Digital sum is nothing but the sum of the digits. Digital sum is nothing but the sum of the digits until a single digit is obtained. 118. 1 plus 1, 2. 2 plus 8, 10. 10 is nothing but 1. 1 square 1. 100 digital sum is 1. 5 ones are, it is nothing but 5. 5 ones are 5. Out of the 4 options, which one is giving you answer? Digital sum 5. 6762, 6862, 6962 and 7062. If I see 6962, 15 plus 6, 21, 21 plus 2, 23. What is 2 plus 3? 5. So if more than one answer option has got the same digital sum, I told you digital sum is an elimination method. It is telling that these 3 are incorrect. If these 3 are incorrect, this will be definitely be right. Answer for this question is 6962. If more than one answer option has got the same digital sum, go back and use the tree method. Disclaimer, remember, digital sum is used to eliminate incorrect answer options. Out of 4, 3 I eliminated. So obviously the remaining will be the answer. I hope it is clear. Digital sum application. First question. Second question. 2-3 questions I will solve so that you will get an idea about this concept. Next one. P is nothing but 2000. P is nothing but 2000. 1 minute, sir. Suppose you forgot these formulae. P is 5000. R is 18%. N is 2 years. Amount is how much? Assume that you forgot the formula. 6762, 6862, 6962 and 7062. You forgot the formula. If you forget the formula, now see here. 18% is nothing but 18 by 100. My friend gave me 100 rupees. After 1 year, I told you already that numerator by denominator. Numerator always represents the change. Denominator represents the initial value. 100. After 1 year, I will give, right, 18 rupees more, so it is 118. It is for 2 years. Second year also it is 100. So this will be 118. 100 into 100. 100 into 100, and it is nothing but 118 into 118. 118 into 118. Now see here, these nothing but 100 into 100 became 5000. 100 into 100 became 5000. 3 zeros are out. 3 zeros are out. I hope it is clear, right? So 3 zeros. These nothing but 1, 2, 3. 3 zeros are out. 10 is divided. 10 is becoming by 5. It is divided by 2. These nothing but 118 whole square divided by 2. 118 whole square divided by 2. Here also you can use a digital sum. 1 plus 1, 2, 2 plus 8, 10, 10 it is 1. 1 square is 1. 1 by 2 equivalent to. See here, 6, 9, 6, 2. 6 plus 9, 15, 21, 23. 2 plus 3, 5. If there is a division, convert the division into multiplication. Convert the division into multiplication. 2 5s are 10. 10 digital sum is nothing but 1. You can also use by using this change concept. You don't need to use that formula. You can also use by using this change concept. I hope it is clear. Idea is clear, right? 118 whole square divided by 2. So 118 digital sum is nothing but 1. 1 by 2. 1 by 2, pick from the answer option. 6, 9, 6, 2. 6 plus 9, 15, 21, 23. 2 plus 3, 5. 5 2s are 10. Digital sum is nothing but 1. Digital sum is nothing but 1. Now please make a note of it, sir. Please make a note. How to use digital sum in fractions? How to use digital sum in fractions? How to use digital sum in fractions? If a fraction is there, how to use a digital sum? A fraction is of the form numerator by denominator. dr is nothing but the denominator. dr is nothing but the denominator. The denominator digital sum. Digital sum is nothing but the sum of the digits. Digital sum is nothing but the sum of the digits. Sum of the digits until you get a single digit number. What are the cases possible? Digital sum is nothing but the sum of the digits until you get a single digit number. These are all the single digit number. Digital sum 0, it is not possible. Digital sum 0, it is not possible. When you are adding digits, how come you will get a 0? So these are the possible. If you get a denominator digital sum 1, it is perfectly okay. If you get a denominator digital sum 2, multiply it by 5, because 2 5s are 10. Idea is to make the denominator digital sum 1. So if the denominator digital sum is 2, multiply by 5. If the denominator digital sum is 5, multiply it by 2. If the denominator digital sum is 4, multiply it by 7. 4 7s are 28. 2 plus 8, 10, which is 1. If the denominator digital sum is 7, multiply it by 4. 7 4s are 28. 2 plus 8, 1. If the denominator digital sum is 8, multiply it by 8. 8 8s are 64. 64 digital sum is nothing but 1. Make the denominator digital sum 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 1. 1 we have taken. 2 over. Write 5 over. 4 over. Next one. 7 over, 8 over. That means if the denominator digital sum is 3, 6 and 9, the denominator digital sum is 3, 6 and 9. This will give you recurring decimal. This will give you recurring decimal. This will give you recurring decimal. Recurring decimal. Recurring decimal. Suppose 1.222. The digital sum is nothing but 4 plus 1, 5. It is 1.22222. 6 plus 1, it is nothing but 7. It is on to, if I keep a bar, 1.2, it is nothing but 3. That means in a recurring decimal, how many times the digit is written, even though if it is not written and kept a bar, if it is written once, twice, the digital sum is changing. Very, very important point. Digital sum will not work when the denominator digital sum is 3, 6 or 9 for fractions. If the denominator digital sum is 3, 6 or 9, it will result in recurring decimal. Recurring decimal digital sum is ineffective. Recurring decimal digital sum is ineffective. Digital sum works for terminating decimals. Digital sum works for terminating decimals. Please make a note in your notebook. Digital sum does not work when the values are approximated. Digital sum does not work for recurring decimals. Digital sum does not work for recurring decimals. Digital sum does not work if the values are approximated. 1.58. Digital sum is nothing but 5. If I approximate it to 1.6, digital sum is 7. Digital sum does not work when the values are approximated. Digital sum does not work for recurring decimals. For recurring decimal. Extremely important slide, sir. Extremely important slide. That means if it is, this is 2, do it with 5. If it is 5, do it with 2. If it is 7, do it with 4. If it is 4, do it with 7. If it is 8, do it with 8. Do it with 8. What are all these? These are nothing but the digital sums of the denominator. Digital sums of the denominator. 1 means it really does not mean 2 by 1 is nothing but 2. For example, 1 by 25. 1 by 25. What is the digital sum? 25 digital sum is 7. Multiply it by 4. This is nothing but 4 by 100. 4 by 1 is nothing but 4. You can also determine the digital sum for fractions if you know this concept. 1 by 722. 1 by 722. 7 plus 2, 9. 9 plus 2, 11. Multiplied by 5. 5 by 1. It will become 5. Denominator anyway it will become 5. Again 1, 9, 3, 6, 5, 4, 7. 9, 3, 6, 5, 4, 7. 9, 3 plus 6, 5 plus 4, 7. If it is 7 multiplied by 4, 4 by 1 it is 4. 4 by 1 it is 4. 23 by 34. 23 by 34. What is the digital sum? 23 by 34. What is the digital sum? 34. 3 plus 4 is 7. So it is nothing but 7. Multiply and divide by 4. 2 plus 3, 4, 5. 5 4s are 20. 20 digital sum is nothing but 2. 20 digital sum is nothing but 2. 17 divided by 53. I will use this concept again in DI comparison of, right? Comparison of percentages and other things. 5 plus 3, 8. 8 is nothing but 8. 1 plus 7, 8. 8 8s are 64. 64 digital sum is 1. How to use digital sum in fractions? I hope it is clear. Kindly reply in the live chat if this concept is clear to you. Click yes, yes, yes in case if it is clear to you. If it is clear to you, kindly reply. I hope it is clear. Why we are using this? Because in compound interest problems, I am getting numerator by denominator. So a student might get a doubt. Sir, when to use a digital sum? Can the digital sum be used in fractions? It can be used in fractions. Remember this important point. Digital sum cannot be used for a recurring decimal. Digital sum cannot be used for a recurring decimal. Digital sum cannot be used for an approximation. for an approximation. If the values are approximated or if the decimal value is a recurring value, please avoid using digital sum. Please avoid using digital sum. Digital sum is very ineffective for a recurring decimal values and for an approximation. That is the demerit of this concept. I hope it is clear. Concept you have understood, and when to apply you have understood, and when not to apply also is clear to you. Now, second one. P is nothing but 2000. R percentage is nothing but 10 percentage. N is nothing but 3 years. N is nothing but 3 years. Amount is how much? 2462, 2562. 2662 and 2762. 2762. Now see here, listen carefully. If I use a digital sum, these are an original exam question, sir. P into 1 plus R percentage power n. 2000 into 100 plus 10. 110 by 100 power 3. 2000 digital sum is 2. 110, 1 plus 1, 2, 2 cube is 8, 100 it is 1, 2 8s are 16, 1 plus 6 it is 7. So, these 6 plus 6, 12, 14, these incorrect, these incorrect, these incorrect. So, answer for this question is 2662. Answer for this question is 2662. I hope the idea is clear. 2662. Hey Anil sir, what if the option is 2626? If the option is 2626, I told you that digital sum is an elimination method. It will eliminate you incorrect answer option A, B and D. 3 options are eliminated. If there is an option 2626, if there is an option 2626, 10 percentage is nothing but 1 by 10. Rate interest is increased. 10 is becoming 11. First year, 10 is becoming 11. Second year, 10 is becoming 11. Third year, these are nothing but 1000. These are nothing but 1331. 11 cube is 1331. 11,000 is becoming 2000 into 2. So it is 1331 into 2. So answer is 2662. Answer is 2662. I hope the idea is clear. A is not out, B is out and D is out because the digital sum is not matching. C and E. C and E. E is out because of this change concept. Because of this change concept. I hope it is clear. Or probably what you can do is, here you can say that 2626 is also incorrect. Why? Because it is nothing but 3 zeros, 3 zeros, 3 plus 3, 6, here 6. So it is nothing but 11 cube, 2 into 11 into 11 into 11. Unit digit is 2 ones are 2, 2 ones are 2. Answer unit digit should be 2, but here the unit digit is 6. So option number E is also eliminated. You can use any of the approaches to solve this question. I hope the idea it is clear. Digital sum will be used to eliminate incorrect answer options. Point number 1. If more than one answer option has got the same digital sum, go and use either the change concept or the tree concept I hope the idea it is clear. Third question in this digital sum. Third question. Sir, what if the amount is given? Amount is 54,880. Original snap exam question. R percentage is nothing but 40 percentage. N is nothing but 3 years. P is nothing but how much? Options are 18,000, 19,000, 20,000, 21,000. 18,000, 19,000, 20,000 and 21,000. Listen carefully here. These are nothing but, amount is nothing but P into 1 plus R percentage power N. So it is nothing but 54880 equivalent to P into 140 by 100 power 3. 140 by 100 power 3. 5 plus 4, 9. Sum of the digits 9 can be eliminated. 8 plus 8, 16, which is 7. P into 140, 1 plus 4, 5, 5 cube is 125, 8. 100 it is 1. Substitute the answer option. 20,000. 20,000 into 8. 20,000. 2 into 8, 16. What is 1 plus 6? 7. 7 equivalent to 7. I hope the idea is clear, right? Keep an eye on answer options always. Sometimes the most difficult questions can be solved very easily if you know these concepts. Keep an eye on answer options using digital sum concept. Digital sum is like an acid test. Digital sum is like an acid test. First, keep an eye on the answer option. If all the answer options have got the same digital sum, this method is ineffective. If you are able to eliminate 3, this is the best method. If you are able to eliminate 2, you can use either a tree method or a change concept to solve this question. I hope this idea it is clear. Digital sum, right? Few problems we discussed and we understood where to use this concept also. Now, what is the another concept that we discussed yesterday? I will just repeat two important concepts. First one, if R percentage is numerator by denominator, R percentage is numerator by denominator, and it is of the form 1 by x, and it is of the form 1 by x. If the time period is 2 years, if the time period is 2 years, listen carefully, for 3 years I will do it. Assume principal equivalent to denominator power k. So it is nothing but x square. So there is first year and there is second year. First year interest is nothing but 1 by x into x square, which is nothing but x. SI for first year and second year it will be same, which is nothing but x. CI it is nothing but SI plus interest on interest. SI plus interest on interest. 1x of x, 1 by x of interest on interest is nothing but 1. It is nothing but 1. Now see here, listen carefully. Total compound interest for 2 years. Total, if the principal is x square, one important conclusion, compound interest for 2 years it will be x plus 1. It is 2x plus 1. Another important conclusion, compound interest for 2 years minus simple interest for 2 years. Simple interest for 2 years is x plus x, 2x. Total compound interest is nothing for 2 years is 2x plus 1, which is nothing but 1. Please make a note of these very, very important concepts, sir. For time period 2 years, if the principal is x square, compound interest for 2 years is 2x plus 1. Compound interest for 2 minus simple interest for 2, the value is nothing but 1. Yesterday we solved few problems. Now I will elaborate this concept for 3 years also after we discuss an application of this concept. What is this concept? Let us first write down. If the principal is x square, if the principal is x square, compound interest for 2 years, compound interest for 2 years, it is nothing but 2x plus 1. Compound interest for 2 years minus simple interest for 2 years, the value is nothing but 1. This when the principal is x square. First question, P is nothing but 49. P is nothing but 49. And this is nothing but R percentage is how much? When CI for 2 years, when CI for 2 years is nothing but 15, which is nothing but 15. 49, which is nothing but 7 square. These is nothing but 2 into 7 plus 1. So R percentage is nothing but 1 by x. So 1 by 7. Answer for this question is 14.2857. Directly just by looking at the question, you will get the answer. If second one, compound interest for 2 years is Compound interest for 2 years is nothing but 31. For 2 years it is nothing but 31. Right? Compound interest is given as 31. Right? Principal is given as 225. 225. Find R percentage. It is nothing but 15 square. These 2 into 15 plus 1. So answer is nothing but 1 by 15, which is nothing but 1 by 3 into 1 by 5, 20 by 3, which is 6.7 percentage approximately. I hope it is clear. Third question. You can solve like that. Any number of questions, sir. Compound interest minus simple interest for 2 years. It is nothing but 12. It is nothing but 12. It is nothing but 12. Now P is nothing but P is nothing but P is nothing but, for example, R percentage is nothing but 10 percentage. R percentage is nothing but 10 percentage. Find the principal. Ci for 2 minus Si for 2 is 12. R is nothing but 10 percentage. Principal is how much? These is nothing but, if it is 1, this will be x square. If these 1, this will be x square. But it is 12. These 12. How much it is? These is nothing but 12 into x square. 12 into x square. What is x value? 10 percentage is 1 by 10. 12 into 100 is 1200. 12 into 100 is 1200. Idea is clear? Very, very important point. If the principal is x square, if the principal is x square, Ci for 2 years is 2x plus 1, Ci for 2 minus Si for 2 is 1. Then you can calculate R. What is R percentage here? R percentage is nothing but 1 by x. R percentage is nothing but 1 by x. First we will write down here. If R percentage is 1 by x and the time period is 2 years, and the time period is 2 years, principal in terms of x will be x square. Compound interest for 2 years, it will be 2x plus 1. 2x plus 1. I hope it is clear, right? Then Si for 2 years will be 2x. Ci for 2 years will be, Ci for second year will be x plus 1. Si for second year will be x. All the values we have done it. Now we will solve. Now we will see time period equivalent to 3 years. Time period is nothing but 3 years. If the time period is 3 years, R percentage is 1 by x. R percentage is 1 by x. There is first year, there is second year, and there is third year. So principal is nothing but denominator power k. It is x cube. First year simple interest 1 by x into x cube, which is x square. Here also x square. Here also x square. For the first year simple interest is x square. Second year x square. Third year also it is x square. In case of second year, Ci is nothing but Si plus interest on interest. So it is 1 by x of x square, which is x. Third year it is nothing but, right, Si plus interest on interest. How many more values are there? 1, 2, 3. 1 by x of x square, x. This is an interest on interest for this. Interest on interest for this. Interest on interest is 1 by x of x is 1. I hope it is clear. Now see here. Now very, very important key point. Si for 3 years. Si for 3 years will be 3x square. Ci for 3 years. Ci for 3 years is x square, x square, x square, 3x square plus x, 3x plus 1. CI for 3, this is important, CI for 3 years minus SI for 3 years minus SI for 3 years, which is 3x plus 1. Please make a note, sir. If R percentage is 1 by x, if R percentage is 1 by x, CI for 3 years minus SI for 3 years is 3x plus 1, then principal is x cube. These three are important. R percentage is 1 by x, P is x cube, CI for 3 minus SI for 3 is 3x plus 1. Anything can be given, sir. Anything can be given. Please make a note of it. R percentage 1 by x, P is x cube, CI for 3 years minus SI for 3 years is 3x plus 1. Now we will write down. If R percentage is 1 by x, if R percentage is 1 by x, principal is nothing but x cube, CI for 3 years minus SI for 3 years, it is given by 3x plus 1. It is given by 3x plus 1. Example, R percentage is 20 percentage. 20 percentage. These nothing but CI for 3 years minus SI for 3 years, which is nothing but, now see here, these nothing but 46. What is the principal value? What is the principal value? These nothing but 1 by 5. These nothing but, these, let us take it as 48. These nothing but 3 into 5 plus 1, 16. If it is 16, I would have got the answer 5 cube, which is 125, because it is 48, which is 3 times. These also will become 3 times. 125 3s are 375. 125 3s are 375. Like that you can solve any question, sir. Suppose if the question is R per CI for 3 minus SI for 3, it is nothing but 88. R percentage is 14.2857. What is P value? 14.2857 is nothing but 1 by 7. So this will be 3 into 7 plus 1, 22. 22 became 88, 4 times. So it is nothing but 4 into 7 cube. 4 into 7 cube. I hope the idea is clear. You don't need to do first year, second year, third year like that. Once you know the concept, these are all very, very easy questions. These are all very, very easy questions. I hope the idea, it is clear. CI for 2 minus SI for 2 we did it, and CI for 3 minus SI for 3 we did it. Now see here, sir, right? There is an important point, important key point. After this slide we will solve problems. If R percentage is 10 percentage, if R percentage is 10 percentage, if R percentage is 10 percentage, this is nothing but 1 by 10. If I take amount after 2 years, amount after 2 years is, principal will become 10 square, which is 100. 1 by 10 of 100, which is nothing but 10. First year. Second year, 1 by 10 of 100, which is nothing but 10. 1 by 10 of 10, which is nothing but 1, which is nothing but 1. Amount after 2 years, this is the first year and it is the second year. Amount after 2 years, it is nothing but 121. 121. Listen carefully, sir. Initially principal is 100. Amount after first year is 110. This is nothing but into 1.1. So this also will be into 1.1. Amount after 2 years is 121. This also will be 1.1. 133.1. This also will be 1.1. This will be 146.41. These also will be 146.41. right? Now these clear, right? If the principal is 100 and the rate is 10%, this is the series that it is following: 100, 110, 121, 133.1, 146.41. Now why am I discussing this? See here, sir. Suppose if the question is P is 700, R is 10%, N is 3 years, N is 3 years. Find the amount. P is 700, R is 10%, N is 3 years. Find the amount. 100, it is growing like this: 110, 121, 133.1 and 146.41. These are nothing but first year, second year, third year and fourth year. So third year, if it is 100, 133.1, 700 is 7 times 100. Amount also is 7 times. 7 into 133.1. 7 into 133.1. Second question. P is 800. R percentage is 10%. N is 2 years. N is 2 years. Amount is how much? After 2 years it is 121. 100 is becoming 800. 8 times. 8 into 121, which is 968. Which is 968. Third one. Amount is nothing but 2662. R percentage is nothing but 10%. N is 3 years. P equivalent to how much? P equivalent to how much? P equivalent to how much? These are nothing but 2 into 1331. So amount is 2 times, principal also 2 times. 133.1 has given me principal 100. 1331 will give me principal 1000. So answer for this question is 2000. Answer for this question is 2000. Any series you get the amounts in this pattern, 121, 133.1, immediately it should strike you. R is nothing but 10%. If you find any values in your questions where the amounts are behaving like 110, 121, 133.1, 146.41, then you can use this concept. This is nothing but an extension of a Pascal's triangle. I will not use that particular word. I hope it is clear. 100, 110, 121, 133.1, 146.41, 146.41. Anything which is of this pattern, immediately it should strike you. R is 10%, and if amount is triple, principal is tripled. Principal is 5 times, amount also is 5 times. Kindly reply in the live chat if the idea is very clear to you. Is the idea very clear? Is the idea very clear? Idea is clear, right? Now we will solve solved problems. Now we will solve a lot of good problems. We will solve. Now first one, see here, sir. First one, some 5 to 10 problems will solve. A principal amount P is given as 625 is invested at compound interest at a 4% per annum for a period of 2 years. So there is a first year and there is a second year. These are nothing but 4% of 625. 4% of 625, which is nothing but 4% of 625, which is nothing but 25, which is nothing but 4 into 6.25. Second year also it is 25. Then there is 4% of 25, which is nothing but 1. So find the compound interest. Total compound interest is nothing but 25, 25, 1. Answer for this question is 51. Answer for this question is 51. Which method I am using? Tree method I am using. In case I'll just give you a glimpse, how can you use other method also. 625, 4 percentage of 625, 25, 25, 4 percentage of 25 is nothing but 1. So total compound interest is 25, 25, 1. Answer is nothing but 51. This is one method. Method 1. This is method 1. You take any method that comes into your mind which will make you solve questions fast. Method 2. 4 percentage per annum. This is nothing but 4 percentage, which is 4 by 100, which is nothing but 1 by 25 for a period of 2 years. First year it is 25, at the end of the year 26. Second year 25, at the end of the year 26. 2 years, right? So this is 625. 26 square is 676. What is the extra compound interest I am giving? Compound interest extra I am giving is nothing but 51. Answer for this question is nothing but 51. Idea clear? Answer for this question is nothing but 51. 4 percentage per annum. Method number 2. Method number 3. Method number 3. Digital sum approach. Method number 3. Digital sum approach. What is this digital sum approach? Digital sum approach. Amount is nothing but principal into 1 plus r percentage power n. So this is nothing but 625 into 100 percentage. R is given as 4 percentage for a period of 2 years. So it is 625 into 104 by 100 power 2. 6 plus 2 8, 8 plus 5 13, 13 is 4. 1 plus 4 5, 5 square is 25 which is 7. 100 is nothing but 1. 47 which is nothing but 28. 28. Now see here. What is 28 digital sum? 28 digital sum is nothing but 1. Amount is nothing but principal plus compound interest. Compound interest is amount minus principal. Amount we got digital sum 1. Principal digital sum is 6 plus 2 8, 8 plus 5 13. 13 is nothing but 4 minus 3. If you get minus, you have to add 9 to it to get the positive digital sum. Minus 3 plus 9 is 6. Answer digital sum should be 6. Answer digital sum should be 6. You can use the digital sum concept, you can use a tree method concept, you can use a change method concept. In all the cases you will get the same right answer. All the cases you will get the same right answer. I hope the idea it is clear. You take any method that comes into your mind. Next one, Rama Rao invested 3000 at compound interest at rate 20 percentage per annum for a period of 2 years. This problem also I will do 3 methods. So these 3000, 20 percentage, these 1 by 5 of 3000 which is 600. Here also it is 600. These 1/5 of 600 which is 120. So total compound interest is 1320. So amount is nothing but 4320. Amount is nothing but 4320. These is nothing but first year. These is nothing but second year. Tree method. Method number 1, tree method. Method number 2. Method number 2, change method. 20 percentage is 1 by 5. 5 1 increase 6. 5 1 increase 6. These is nothing but 25 became 36. 25 became 36. But I want 3000. But I want 3000. Now see here, sir. You don't need to do. These are nothing but 25 ones are 25. These 120. It is into 120. Don't multiply. 36 digital sum is 9. 9 into any number. Answer digital sum should be 9. Answer digital sum should be 9. Answer digital sum should be 9. So these, how much it is? 4 plus 3, 7, 7 plus 2, 9. Second option. right? Or if you multiply 12 6 are 72, answer is 4320. Answer is 4320. Method 1 is nothing but interest on interest method. Method 2 is nothing but the change method. Method 2 is nothing but the change method. Method 3, can I use digital sum? First two problems, right? I'll just give you an idea. Then you decide which method to choose depending upon your practice. Amount is nothing but P into 1 plus R percentage power N. This is 3000 into 120 by 100 power 2. Here you don't need to do it. It is 3. 1 plus 2, 3. 3 square is 9. Answer digital sum should be 9. Answer digital sum should be 9. So answer is 4320. Answer is 4320. This is not possible, not possible, not possible. I hope this problem is clear to you. Second one. Third one, what is that we discussed? If the principal is x square, ci for 2 minus si for 2, this will be 1 when r percentage is nothing but 1 by x. R percentage is nothing but 1 by x. Find the difference between 2 years compound interest and 2 year simple interest on sum 5000. These is nothing but 5000. If the rate of interest is 20 percentage, 20 percentage is 1 by 5. These is nothing but 1 by 5. These 1 by 5 when the value for P is nothing but 25. These into 200. Are you with me? So 1 into 200. Answer is nothing but 200. So if R percentage is 1 by 5, principal is 5 square 25. But in the question it is 5000. So into 200. Into 200. Next one. All these are very, very easy, sir. R percentage is 14.2857 percentage, which is given in the question, which is nothing but 1 by 7. If it is 1 by 7, these is nothing but 7 square 49. Ci for 2 minus Si for 2. This will be the 1. We have already discussed it. But 49 is becoming, how much it is? 7350. It is becoming 7350. So 49 ones are 49. 245, 150, 1 into 150. Answer for the next question is 150. Just by looking at the question itself, you are getting the answer. This is nothing but 150. Next one, rate of interest is 12.5 percentage, which is nothing but 1 by 8. Rate is nothing but 1 by 8. Principal will become 64. Ci for 2 minus Si for 2. This will become 1. But according to the question, difference between 2 year compound interest and 2 year simple interest, it is 25. So it is 1 into 25. This will also become 64 into 25. 25 is nothing but 100 by 4. So answer is nothing but 1600. Very, very easy. Just with fastest time you can solve it if you know these approaches. I hope the idea it is clear. Next one. The difference between 2 year compound interest and 2 year simple interest. Here it is not of the form 1 by x. It is not of the form 1 by x. Find the principal amount. Now see here. Ci for 2 minus Si for 2. It is nothing but 128. It is nothing but 128. R is nothing but 8 percentage per annum. R is nothing but 8 percentage per annum. Now see here. Suppose if I take answer option 20,000. If I pick 20,000 as the answer, I will tell you on what basis I am picking. This is the first year and it is the second year. So first year it is 8 percentage of 20,000. 8 percentage of 20,000. These is nothing but by 100 2 zeros cancel. These 1600. Here also it is 1600. 8 percentage of 1600. These is nothing but 8 into 16 128. Difference between Ci for 2 minus Si for 2 is nothing but 128. I hope it is clear. 128. Idea is clear, right? So these is nothing but 128. So how am I picking is, now see here, these is nothing but this value, these 1600, these 1600, these is nothing but 8 percentage of 1600. I hope it is clear. Now what I will do is, on what basis I picked? First option, 8 percentage of 18,000. These is nothing but 1440. Now again if I do 8 percentage of 1440, 8 fours are 32, unit digit is 2. I want unit digit. I want unit digit. I want unit digit as how much I want? I want 8. Suppose if I pick 8 percentage of 20,000. These is nothing but 1600. Again 8 percentage of 1600. 8 6 are 48. Now we will come to the single step. I hope it is clear. So what am I doing is, in case of Ci, because it is Ci, it is interest on interest. It is interest on interest. It is interest on interest. First it is interest is 8 percentage of x. Again on this interest, this is 8 percentage of x. It is 8 percentage of x. I hope it is clear, right? Now see here, where it is giving, it is nothing but 128. 8 8s are 64. This is 4. This unit digit is 8. So I should get this value as 2. So this is nothing but, answer is nothing but 20,000. 4 2s are 8. 4 2s are 8. I hope it is clear. Or you can use digital sum. Digital sum can also be used. 8 8s are 64, which is 1. 1 into x is nothing but 2. X is nothing but 20,000. Digital sum is 2. 1 2s are 2. Either you can pick from the answer option, either you can use the unit digit logic, or you can do it. See here, sir, percentage is 200s. 200s, 4 zeros are eliminated. 8 8s are 64, 64 2s are 128. That is what I got the answer. Either an unit digit logic you can use, or a digital sum logic also you can use to solve these questions. I hope the idea it is clear. Next one, a person invested certain amount at a simple interest at the rate of 6% per annum, earning 900 as an interest at the end of 3 years. R percentage is nothing but 6%. This time period is nothing but 3 years. So simple interest for 3 years, it is nothing but 18%. 18%. So 18% of actual principal is nothing but 900. These is nothing but 5,000. Principal is 5,000. Had the interest been compounded every year, how much more interest would you have earned on the same amount after 3 years? After 3 years, how much more you would have earned? R is nothing but 5%. N is nothing but 3 years. N is nothing but 3 years. Now see here. So these is nothing but, you can do it in multiple methods. Amount is nothing but principal P into 1 plus R percentage power N. Power N. So amount is nothing but 5,000 into 105 by 100 power 3. These is nothing but, these digital sum is 9. These digital sum is 9. I hope it is clear. This digital sum is 9. So amount compound interest is nothing but amount minus principal, right? If you do, you will get the digital sum. This is one method. Another method is, now see here, I will do one slowly, sir. Idea is clear, right? 6% given on simple interest. For 3 years total, it will be 18%. So P is 5,000. If P is 5,000, N is 3 years. N is 3 years. R is nothing but 6%. How much more interest you would have earned on the same amount after 3 years? So first year, second year, and third year. First year it is nothing but 5,000 into 6%, which is 300. Here also 300. Here also 300. I hope it is clear. 300 of 6%, which is nothing but 18. 18. Here also it is 18. For this 300, 18. For this 300, it is 18. Next one, 6% of 18, which is nothing but 6% is 108, 1.08, 1.08. What is the question? What is the, how much more interest you would have earned on the same amount with the same interest after 3 years? So simple interest we know for 3 years. Compound interest, how much it will be? 18, 18, 18. More interest. More is nothing but, CI is nothing but 18 into 3 plus 1.08. So answer for this question is 55.08. 55.08. While calculating digital sum in the question, please be a little careful, right? The question is, how much more interest? The digital sum will give you total compound interest. More means some changes needs to be done. Answer is 55.08. I hope the idea it is clear. The difference between 2-year compound interest, now already we did it. So this is nothing but, CI is nothing but, CI for 2. Now see here, same similar question, we did it. CI for 2 minus SI for 2, it is nothing but 72. R percentage is nothing but 12%. So first year and second year, let me take here first year and it is second year. Difference, right? So if I take first option, 12% of 5,000, traditional method, these is nothing but 12 into 500, these 600, these 600, these is nothing but 12% of 600, which is nothing but 72. 72 is what we want. So answer is nothing but 72. Now if you see here, these is nothing but, what is this 12% of 600? These is nothing but 12% of 5,000 and it is 12% of 6,000. Am I right? So these is nothing but, it is nothing but, answer is nothing but, very easy. Just by looking at a question itself, you will get 12% and into 12% into something. It is nothing but 72. It is nothing but 72. Now see here, you go by the answer option. 12 12s are 144, 144, right? 14.4 into 5, which is 72. The good thing about this question is 3 3s are 9. 9 into any number I will get. 9 into any number I will get digital sum 9. So digital sum is not the effective method here. Effective method here. I hope it is clear. 2 2s are 4. So 4 into 5, 20. Digital sum unit digit is 2. Digital sum 9 into any number, digital sum is 9. I hope these ideas are clear to you. So what are all the various problems that we discussed? Various problems we discussed are, right, CI series, CI amount values are in geometric progression. If 3 amounts are given middle value is the square root of the previous and later. Multiplication factor remains the same. Ci for 2 minus Si for 2. How to get the answer? Ci for 3 minus Si for 3. How to get the answer? And some problems based on unit digit, based on digital sum. I hope it is clear. These are nothing but 144 divided by 100 into 100 into 100 into 5000. 3 zeros cancel. So these are nothing but, if you observe, 14.4, right? 14.4 into 5, which is 72. So answer is nothing but 72. I hope all these problems are clear to you.